sampling distribution. Before going to discuss about sampling distribution, first we are going to know the basic concepts related to sampling distribution. Next you can understand what is exact sampling distribution. So here, first we are going to discuss one fundamental definition, population. Population means in statistics, that is totality of data. Totality of data. In one word we can say like this. Totality of data. So totality of data represent population. That means, for example, if we are collecting information regarding one subject, the data related to that complete subject is population for that subject. If you are collecting data for one concept, if you collect some data related to that concept, the total data is called population. In statistics, in general way we know population means that is a count of people like that. But here we are discussing statistic analysis of data. In the case of data, total data we are treating as population. If you take an example of rice bag, a rice bag contains rice. The total rice is population of that rice bag. But with the population, one cannot understand the nature of the data. To know the nature of the data, to describe about the data, you need a sample. Just now I said one example, rice bag. So if you see the rice bag, you cannot identify the quality of that rice which is in the rice bag. But if you take some rice pieces from that rice bag, you can decide, you can describe about the quality of that rice bag. So sample plays key role to know about population, to describe about population. So sample is nothing, simply we can say that is subset of population. Subset of population is sample, which describes about population. The best example in our day-to-day life we can say about sample. If you are cooking rice, one piece of rice piece is enough to decide the rice is boiled or not. You are not going to check every rice piece, right? So the total rice which you are boiling comes under population. That single rice piece which you are taking to test the rice is boiled or not, that rice piece comes under sample. That sample describes complete nature of population. So sample plays key role. Here our discussion also sampling distribution. Sampling, the process of getting sample from the population. The process of the way you are taking sample from population, getting sample from population. In very simple way. Getting sample from population. How you are going to get a sample from population, how you are taking. That process is called sampling. There are so many types of sampling techniques. In that, we are going to discuss few. That is random sampling. Random sampling. So random sampling means getting a sample from population in random way. As per definition, how we can define random sampling? Random sampling, if you take sample from population in random sampling, if you take n samples, they have equal chance of getting. They won't depend on each other. The samples, if you draw from population n number of samples, that n number of samples have equal chance of getting. Equal chance of getting for every sample. That type of sampling we can call it as random sampling. So if you want to buy fruit, you went to fruit vendor, there you need to test the quality of fruits. For that, what you will do, randomly you will pick a fruit. That is called random sampling. Generally, we go for random sampling to know about the population very clearly, without any intention. In that, simple sampling. Simple sampling is one type of random sampling in which drawing one sample does not depend on any other samples. A sample does not depend on previous sample. Previous one. So if you take two samples from the population, one sample does not depend on another. Just now I said getting fruits. You tested one fruit, whether it is sweet or not, or to test the quality. If you won't feel good, you will check one more time. That is comes under simple sampling. That another fruit which you are taking, that won't depend on previous one. That type of sampling, simple sampling. Okay, next, stratified sampling. Stratified. When the data is too large, that one sample is not enough to decide the nature of population. Then you will divide the large population into some small spots. From every part you will take one sample to test the nature. That small spots is called strata. Strata means one portion of the population which we can call it as one type of sample. But that is a large sample. When you want to get some data of some particular state employees, then you cannot get directly. First districts, mandals, like that. Mandals, districts, like that. If you separate that employees data, from that data if you take the samples, we call that one as stratified sample. Whenever if you want to check the quality of a large segment of fruits, one fruit is not enough to decide that large segment. You need to divide into some portions. From every portion if you take one sample, then you can judge correctly the quality of that fruit. That is stratified sample. Dividing the data when size of the population is too large. Divide that one into portions. Purposive sampling. So purposive sampling means, name itself says meaning, with a particular purpose. The sampling, we will take the sample. In purposive sampling, he has a particular purpose. Just now I said one example in fruit vendor. So, if you want to check the quality of the fruit yourself, you will go for random sampling. But if fruit vendor wants to show his fruits quality, he has a particular purpose. That purpose is, he feels that he wants to show that his fruits are very good quality. For that, what he will do, already in the starting itself, he will check some fruits by taking some samples. In that, the good fruit, sweetest fruit, he will cut and he will keep aside. Whenever he want to show the quality or taste of that fruit, he will cut that fruit and he will give you. So there, the fruit vendor's purpose is, he want to show his fruits are very sweet. So that type of sampling is purposive sampling. Okay, sampling with a particular purpose, which won't gives a good results, which won't describes in correct way of population. So this is some sampling techniques. Now we are discussing about sample. Here sample means subset of population, but basing on the size of the sample, the samples are classified into two types. Size of sample, number of elements or number of objects in the sample. Generally, we represent this one with small n. Size of sample. Basing on size of sample, samples are classified into two types. They are large sample and small sample. Large and small. Large sample. Large sample means if size of sample greater than 30, greater than or equal to 30, then that sample is called large sample. If size of sample greater than or equal to 30, we call that one as large sample. If size of sample less than 30, we call that one as small sample. Small sample means size of sample is less than 30. So basing on size of sample, we can classify sample broadly into two types. They are large sample and small sample. The sample which you are taking from population, it has size less than 30, we call that one as small sample. If the size of sample is greater than or equal to 30, we call that one as large sample. So basing on size of sample, we will describe the nature of population. We will discuss in detail about large and small sample. They are separate topics. First, what is small sample means? Basing on size of sample. If size of sample is less than 30, we call that is small. Greater than or equal to 30, large. So now we are coming to our actual topic. What is sampling distribution? So sampling distribution means whenever some samples are taken from the population. For example, n samples are taken, x1, x2, so on, xn, were taken from the population of size n. Here, size of sample I said small n, population size we will represent with capital N. If n samples are taken from one population, for these n samples, we are going to calculate the mean of samples. Mean of samples means adding all the samples, x1 plus x2 plus so on plus xn by n. Mean definition, average, sum of items by number of items, that is mean of that n samples. We represent this one with x bar. Finding variance or SD. Variance means sigma square, SD is root sigma square. Sigma x minus x bar whole square by n. If you keep here I is from 1 to n. Calculating these are all comes under sampling distributions. We are distributing sample and we are calculating some sample measurements in that distribution. Mean, sample mean, x bar, variance, sigma square. Like that, after drawing the samples from the population, we can draw the samples from the population in two different ways basing on how we are taking the samples, with replacement or without replacement. Without replacement, if size of sample is capital N, size of sample is small n, size of sample. Capital N is size of population. Size of population. Here, basing on how you are taking the samples from the population. If you take n samples from population of size n, without replacement, NCN, without replacement. Without replacement. With replacement, we will get n power n. With replacement. So after drawing these samples, we are going to find for NCN samples mean and for NCN samples variance, After finding for NCN samples mean, again we are going to find mean of sample means, which is called mean of means, SD of means. If you want SD, we will take square root of sigma x minus x bar whole square by n. So here we are discussing two types of symbols. This is a square. So this is variance, this is mean. Another symbols which we use for representing mean and variance, mu and sigma. So mu sigma we represent for population. Mu is population mean. These two are related to population. Population mean is represented by mean, mu. Population SD is represented by sigma. Population variance sigma square. Similarly, sample mean is represented by x bar. Sample SD is represented by S. These two are related to sample. So, like this, the population related measurements are called parameter. The population related measurements, we call them as parameter. Sample related measurements like x bar and S are called static. So whenever if you get a parameter, we are discussing about population. Whenever we are discussing about a statistic, that means we are discussing about sample related measurements. Are you clear? So this is about sampling distribution. Okay. A population consists of 5 numbers. That numbers are given 2, 3, 6, 8, 11. Consider all possible samples of size 2 which can be drawn without replacement from the population. Next we need to find mean of population, SD of population, mean of sampling distribution of means and SD of sampling distribution of means. Before going to the actual evaluation of mean of population everything, first we need to prepare samples of size 2 from the given population. So actually given population is 2, 3, 6, 8, 11. So size is given. So population size generally represented with capital N. So size of population is given very clearly. Size of population is 5. And also size of sample is given. Size of sample 2. So we need to prepare size of sample 2 without replacement. There is a formula to find the number of samples we are going to get from the size of population capital N, from the size of sample small n is NCN formula. So here the number of samples of size n from population of size capital N without replacement is NCN. Here size of population we represented with capital N and size of sample we represented with small n. NCN means capital N is 5, C small n is 2. So you can get this value from your calculator directly, or you can use this shortcut. If you have 2 here, write in numerator from 5 decreasing 1. Product 5 minus 1 4 by in the denominator write from 2 decrease up to 1, 2 into 1. 2 1s are 2 2s are 5 2s are 10. So 5's 2 value is 10. You can use your calculator directly, you will get 10. So now we are going to get 10 samples from this population of size 2. What are the 10 samples? So we need to pair with 2 first, next 3, next 6, next 8, next 11. So that samples without replacement means the sample which you written, don't write that one again. What I am saying, you written now 2 3, don't write 3 2. Next 2 6, 2 8, 2 11. With 2 you can pair all. But while coming to 3, you cannot write 3 2 without replacement. That means from here you will write 3 6, 3 8, 3 11. So now taking next number 6, you cannot get 6 3 6 2. They are here. That's why from 6 8 you need to write 6 8, 6 11. With 8 you will get only 1, 8 11. You cannot pair 8 with any other number, already it is paired with other numbers. So if you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 samples you will get without replacement. With replacement you will get n power n, 5 square, 25. There you can write 2, 3 and 3, 2. 2, 6 and 6, 2. Like that, for every element you will get 5, 5. With 2 you can write 5, with 3 you can write 5, with 6 you can write 5, like that 5 5s are. So with replacement, that is. Now our case is without replacement. So without replacement, like this we can prepare the samples. Now come to our question. What is first bit? The mean of population. Mean of population means the population items 5 we are having, sum of items by number of items. Very simple. Mean of population. Mean of population is represented with the symbol mu. Because population mean we need to use mu. Formula is sum of items by number of items. Sum of population items. Population items are 2, 3, 6, 8, 11 by the number of items. Sum of items by number of items simply. So if you add these all and if you divide, you will get 30 by 5. So you will get 6. That is mu. Population mean is 6. Next, second bit. SD of population, standard deviation. SD of population has formula. SD of population, root of x minus mu whole square by sigma. If you write here xi, I equal to 1 to n. Sigma xi minus mu whole square by n. That means you need to subtract this mu from every element of population and you have to square. What I am saying, square root of 2 first element minus mu, 2 minus 6 whole square plus 3 minus 6 whole square plus 6 minus 6 whole square plus 8 minus 6 whole square plus 11 minus 6 whole square by total. So this is SD of population. So if you calculate this one using your calculator, you will get 3.29. Use Calci for calculating these all. So coming to the next bit, third bit, what you are having, mean of sampling distribution of means. Mean of means. Very simply what we can say, this is mean of means. So that means first we need to find mean of samples. Here we are having 10 samples. For each sample you need to calculate the mean. So how many means you will get? You are having 10 samples, you will get 10 means. For that means again you need to calculate mean. That is called mean of sampling distribution of means. So first I am calculating mean of samples. These mean of samples are very easy to calculate because size of sample is 2. So mean of 2 items is sum of 2 items by number of items 2. So 2 plus 3 by 2. 2 plus 3, 5. 5 by 2. 2.5. This 2.5 you got like this. Like that, you need to calculate for 10 samples. So first sample 2 plus 3 by 2. Second sample 2 plus 6 by 2, 8 by 2, 4. 10 by 2, 5. 2 plus 11, 13 by 2, 6.5. Next, 3 plus 6, 9. 4.5, 3 plus 8, 11, 11 by 2, 5.5, 3 plus 11, here you will get 14, 14 by 2, 7, next 6 plus 8, again 14, 14 by 2, 7, 6 plus 11, 17, 17 by 2, 8.5, 8 plus 11, 19, 19 by 2, 9.5. Like this, you will get the mean of 10 samples. These are mean of samples, but we need mean of means. Mean of sampling distribution of means. This is sampling distribution of means. For this again we need to calculate mean. This one. Mean of sampling distribution of means. Sampling distribution of means. So this can be calculated simply sum of items by number of items. You need to add the 10 samples and divide with 10. So if you add this 10 like this, 2.5 plus 4.5 plus 5 plus 6.5 plus 4.5 plus 5.5 plus 7 plus 7 plus 8.5 plus 9.5 by 10. So if you do this mean of sampling distribution of means, you will get 6. Generally, the value which you will get here may be approximately that value only will get. Mu value and x bar value will be same. So now 6. Next, we need to find D bit. What is D? SD of sampling distribution of means. SD of sampling distribution. Sampling distribution of means. So two ways of finding like this. Sigma x minus x bar whole square by n minus 1 we can use. Otherwise, there is another formula to find SD of means when we know capital N and small n. Like this one can easily find out. Sigma by root n into capital N minus small n by capital N minus 1. We call this one as correction factor. Sometimes for short answer, population size and sample size is given. Find correction factor, this one, capital N minus small n by capital N minus 1. You know all the values. Sigma value we calculated here, this one. Sigma is this one. SD of population we represent with sigma. Sigma is 3.29. Small n we are having 2. So substitute capital N we are having 3.29 by root 2 into square root of capital N 5 minus 2 by 5 minus 1. If we calculate this, approximately we will get 2.012. Like this one can easily calculate mean of population, SD of population, mean of sampling distribution of means. Everything one can easily calculate.